My colleagues and I are doing research based on the ring topologies. My colleagues include Micah Imani Swain, Daniel Isaacs, Tej Johnson, Timothy Marquet, Christian Swebe, and I, Ethan Chan. This is the model of the ring topology. This model is made out of cardboard, wood, fishing wire, and cartridge paper.
In a ring network, data travels from node to node in either clockwise or anti-clockwise direction. When there's a break in the cable, this interferes with the flow of the data.
Node failure or cable break might isolate every node attached to the ring. In response, some ring networks add a counter-rotating ring, aka the C-ring, to form a redundant topology.
For example, if there's a break in the cable going from the server to the computer, the printer and the cell phone would not be able to communicate with the computer if it's traveling in a clockwise direction. Some ring topologies, after having a cable break, isolate the nodes that are still working and make it into a C topology.
Every token ring network is built in a star-wired ring topology. The network is physically wired with all nodes connecting to a device called a multi-station access unit, MSAU, in a layout which resembles a star topology. The MSAUs are connected together in a ring topology. The MSAU is the heart of every token ring network. It is a hub or concentrator that connects a group of computers, referred to as nodes in network terminology. Every MSAU has two special purpose ports marked ring in and ring out. These ports are only able to interconnect MSAUs and cannot be used to connect to PCs, printers, or any other network device. The MSAU also has at least two load ports. These ports are used to connect to network devices only and cannot be used to interconnect MSAUs. Besides an MSAU, another requisite hardware in the configuration of a token ring topology is the cable. Only three specific cable types can be used in a token ring topology. The first cable type, the unshielded twisted pair or UTP, which is currently the most popular cable type for new networks, has the ability to support almost any network technology currently available, and due to its small physical size, it is easy to work with. The disadvantage of using unshielded twisted pairs in a token ring network is that it drastically limits the size of the ring, especially at 16 megabytes per second. The second cable type is the shielded twisted pair. It is similar to the UTP, but with each pair covered by an additional copper braid jacket or foil wrapping, which helps to protect the signals on the cables from external interference. The third cable type is the fiber optics cable. The primary use of the fiber optics cables is to extend the size of the ring interconnecting MSAUs beyond its normal limitations. It is also occasionally used to connect workstations where security or long distance is needed.
Of a ring topology. All data flows in one direction, reducing the chance of pocket collisions. A network server is not needed to control network connectivity between each. As usual, there are always disadvantages. All data being transferred over the network must pass through each workstation of the network, which can make it slower than a star topology. The entire network will be impacted if one workstation shuts down.
A bus network relies on a physical cable to transmit data, send instructions, etc. This means that the network may be subject to easier damage as it is a physical damage, which can be damaged if not kept in a secure environment. The ring does excel in its isolation of fault, which is very straightforward, while the bus is more complicated. The bus also suffers from signal reflections in the cable, and this requires caution about impedance mismatches at nodes. A fully connected mesh networks are very expensive in comparison to the ring network due to the fully connected mesh being connected to every computer. On a star network, there's one central hub with many nodes spreading from it. All data transfers must go through the central hub/switch before it being transmitted to the intended receiver. The ring network is better suited for transmitting data to other devices quickly, and it works better over longer distances. Like the hybrid network, tree topology requires a lot of infrastructure and maintenance. This is because it is a combination of a bus network and a star network. Due to this, a lot of cables and wires and cooling devices are needed, which charge very high prices. Also, maintenance is needed frequently, which can be a nuisance and costly as well. With continued addition of more and more nodes and segments, maintenance becomes more complicated, which requires skilled workers who work for higher pay. It relies mainly on the central bus cable, and if that cable is damaged or broken, the entire system could feel those effects. Hybrid topologies are more complex than the ring network as they incorporate multiple networks, but this comes at a high cost. The design of connecting two different networks is very complex, and it requires a lot of work from the designers. To perform an installation needs to be very efficient. The central hub that a hybrid network needs are expensive, and they need to be very specifically designed and intelligent.